There we go. Now my hand doesn't cover the camera. So the other ones, the money ones, it's all based on this equation. And you'll usually know two parts and you find the other two. And it doesn't have to be money. It could be, like your homework, it's bacteria. So you just got to look at the time. The K is your rate of change, and then your initial value, and then whatever you end up with. So like, if your initial is, I don't know, like doing one of the homework ones. If your initial is 1,000 and your rate is 8.6, find the doubling time and amount after 30 years. Okay, well, doubling time's pretty simple. Your initial is 1,000, so I'm just plugging stuff in here. So what am I going to end up with at the end? Well, I'm going to end up with double, so I'm going to put 2,000 there. So how long will it take me? E to the 0.086 t. Solve for t. That's it. So I would divide by 1,000. So that's 2 equals e to the 0.086 t ln it. So it's ln of 2 equals 0.086 t divided by 0.086. And that's how you would get t, whatever that is. I don't know. And then, so your 30 years, you would just plug everything. So it's how much would you have after 30 years? So I don't know what y is, but I know my initial value, I know the rate, and I know time is 30 years. So plug that in, boom, you got your answer, whatever that is. Let's say you had one where, is there anywhere you didn't know the, oh yeah, there was somewhere you didn't know the rate. Like there was one where it gave you the initial value, 2,000. You don't know the rate, and you want to find the, and it gave you the doubling time as 15 years. Okay, well, same equation. Plug in your initial value, e to the k, I don't know, rate's 15, or k is the rate, doubling time, years is 15. What'll that equal? Well, this is the doubling time, isn't it? So isn't it going to double after 15 years? So now I just find the rate, solve for k. Same thing, divide by 2,000, same thing we just did here. Here's solve for the other one. Divide by 2,000, ln of 2 equals 15k, divide by 15, you get the point. So then you would have your k. So it's all the same, just plugging stuff in, plugging in what you know, figuring out what to plug in, and solving. And your homework though, on number either 19 or 20, whichever one I assigned, 19, you have to find the, it says find the amount of time required for a $2,000 investment to double. Well, and then it says A, annually, B, monthly, C, quarterly, and D, continuously. For A through C, when it's compounded annually, monthly, quarterly, you're going to use just like a b to the x, if you remember how to do that from Algebra 2. You don't have to, I guess. You know what, just forget about that. Just use whatever you want. Be creative. Just keep in mind if it's compounded, like, they give you an annual interest rate. So on 19, it's 4.75%. And so if it's compounded annually, you just use your rate, or your K, whichever one you're using, or B if you're using this one, K the other one. It'd be 0.0475. But like on B, when it says it's compounded monthly, you have to divide 4.75 by 12 and use that. Or C, if it's compounded quarterly, you have to divide 4.75 by 4 and use that rate. And then compound it continuously, you just use the 4.75 again. I think that's it. And then 24, just use the same idea as these right here. Just plugging in what you know. Like I said, there's really not a lot of the calculus in this is just in the proof. And, well, I guess we could do that if you want. It's really not a hard proof. It's really just a few minutes, but that's it. Just reminding you what your homework is. Some of you might not have written it down because it was right at the end. There it is. Have fun with that. I'm going to do it right now, actually, too.